Stay classy, Golden Eagles. So this is going to be a video learning about our new concept and our new learning target. But before we get into that, I want to do a little bit of clarification based on last week's lesson. I think there might be a little bit of confusion out there. So the first lesson of last week had you guys naming, and let me get the paper out so I can clearly see, have you naming triangles. Now, naming triangles is different from classifying triangles. Classifying triangles is what we did in our second lesson from last week, where we classified triangles as either right, obtuse, or acute. Naming is different than classifying. So naming was like GHI, ABC, triangle GHI, triangle ABC, and that kind of thing. Classifying is different. So I was thinking of an analogy that could help you guys to better understand that. Let's think about a dog. Okay, so I'm going to use Kyla Holbrook in my class as an example, and her dog Thor. Okay, so her dog is named Thor. Let's think about that as same thing as naming triangles. Kyla and her family named their dog Thor. Now, Thor is a dog, but if you were to classify what breed of dog he would be, he is a black lab. And that's where the classification comes in. It's not necessarily so much a name, but it's how you can classify a different triangle more than its name. So Kyla's dog is named Thor. She can classify it as a black lab. That type of thing, okay? So last week we went over naming triangles. Remember, when you're naming a triangle, it always starts with the shape triangle. And then based on the vertices, which are where two sides meet at a point, you can name it. And I'm looking at an example here from last week. This was what you guys worked on last week. I'm looking at here, and you could name this triangle STU or UST, okay? That type of thing. And then the next lesson that you guys learned about from last week was classifying triangles. Remember, classifying is different from naming. It still can be triangle TSU, but is triangle TSU a right triangle? Is it is it an obtuse triangle, or is it an acute triangle? And last week we were classifying based on angles, okay? And this week we're going to change it up a little bit, and we're going to classify triangles based on their sides. So our learning target this week is I will be able to classify triangles by sides. So that'll be our learning target for this week, okay? So in theory, a triangle can have many different, it can have a name, and it can have multiple classifications, and we'll get into that. But we're really only going to be focused on classifying by sides right now. Eventually, later on in this week, we're going to get into we're going to get into naming triangles. We're going to get into classifying triangles by angles and sides, and you'll do all three with one triangle, okay? So the first, and as there were with classifying by angles, there are three types of classifications for sides, okay? And sides is what we're going to be doing is based off the length of each side. And a triangle has three sides, therefore tri. Tri is three. The first one that I want to look at is called a scalene triangle or a scalene triangle, okay? And that is a triangle that has no equal sides. Now, let me get the piece of paper behind it out of the way so it's easier to see. A scalene or a saline triangle has no equal sides. And here's the example that I have before you. Now, if you look at the length of this side, it's pretty short, and it's certainly not equal to this side or this side, right? Yeah, that one's clear. Now, you can also look, and we can compare these other two, okay? Now, this one seems to me to be the longest. This one's close to being the length, but it is not the same length. So therefore, it has no equal sides. Now, on occasion, it won't be the case for you guys in your work this week. On occasion, you will see an indicator or something that is helpful, or an indicator is a good word, to show you that which sides are equal length. And you use it just with little tally marks. Now, here's what it would look like for a scalene or a saline triangle. Now, the one mark indicates that this is this length. 2 marks indicates that it is this length, and 3 marks indicates that it is this length. Now, if these two sides happen to be the same length, they would have the same number of tally points. But since we only have a 1 here, a 2, and a 3, that indicates that they are not equal in length. So this therefore makes they have no equal sides of length. Therefore, it's a scalene or a saline triangle. The next one that we're going to work with is going to be in what's called an isosceles triangle. And an isosceles triangle is a triangle with two equal sides. Okay, now here's the example that I provided for you. So an isosceles triangle has two equal sides. We can see the bottom part of this isosceles, the bottom side is very short, and it certainly is not an equal length of this side or this side. Okay, and then if we compare these two sides, you can see, and without getting out a measuring a ruler and measuring it, you can see that yeah, these two sides here are equal length. So therefore we have two sides that are equal length. So therefore it is an isosceles triangle. And what we talked about with the tally marks, we can go ahead and show again. Now we will indicate one tally mark for one side. And since we identified these two sides as being the same length, we're going to each give them two tally marks. And if you happen to see that, you would then know, oh, this is its own length because there's no other side that has just one tally mark. But then you see these two sides and be like, oh, they have two tally marks. That's telling me they are both the same length. Therefore, it is an isosceles triangle. And last but not least is an equilateral triangle. An equilateral triangle has a code in it already. It says equal. And an equilateral triangle is a triangle where all three sides are the same length. Okay, so a triangle with all equal sides. Okay, so you can see, and I drew this to the best of my ability, that this particular triangle has all equal sides. All sides are equal in length. And therefore, we could even go through with the tallying marks that we've been talking about. And we can just do one. And if you happen to see an example like this, where the tally marks show that, that tells you it's all equal sides. Or what you guys will be doing is just doing your best judgment off of visual clues, okay? So an equilateral triangle has all equal sides. So looking at this, if it did not have the tally marks, we could look at it and say that within reason that all three sides of this triangle are equal length. Going back to our example from an isosceles triangle, remember isosceles has two equal sides. You can think about it as eyes, two eyes. It has two equal sides and one side that is not equal. And last but not least, a saline or a scalene triangle, I've heard it pronounced multiple ways, where no sides are equal. Okay? This side certainly is not the same length as this one or this one, and this side is not the same length as this or this. So therefore it has no equal sides, and it is a scalene or saline triangle. Okay, so our goal today, ladies and gentlemen, is just a quick review. Our learning target is you will be able to classify triangles by their sides. And there are three options. There is the equilateral, or all sides are equal. There is the isosceles, eyes has two equal sides. And there is the scalene or the saline triangle, which has no equal sides, okay? So go ahead and today work for me on page 7. There's 7 problems. Right underneath or in your Google Doc, write for me what they are in terms of an equilateral, scalene, or isosceles triangle. And guys, Mr. Holt and I are expecting you guys to spell these correctly because we're giving you those examples, those correct spellings are in the worksheet. If you have any questions, email myself or leave a comment below. As always, stay classy, Golden Eagles.